Right. Hi. Today we are going to look at critical path. How are you going to identify the critical path? Now, what is a critical path? Critical path is actually the longest time path between the start and the end of the network. And from here, it's actually telling you the project completion time. Now, why are we actually looking at the longest time path? For example, if you are actually looking at a project, right, the project of building the MRT network, right? So let's say you are the actually contractor, you're trying to build the MRT network and you're trying to tender for the project, right? You are representing the company here. So when you are looking at building the infrastructure, you will always have some good scenario and bad scenario. For example, when the weather is good, definitely the project can be conducted smoothly or executed smoothly. You can build the network. Let's say there's no rain, the weather is good, your supply, everything is there. So let's say you can finish it within 6 months. But then you have a bad scenario or worst case scenario where let's say you have shortage of supply, you have probably flood, right? Things like that, right? Then would cause a delay into your project. So let's say if you have a bad case scenario, the project instead of 6 months, it will take you 9 months. So when you are actually tendering for the project, which one would you submit for the tender? Would you go for 6 or 9? If you go for 6, what will happen should the worst case scenario actually happen? Therefore, you will have to pay penalty because there's a delay, right? If you go for this, you will have a delay. So in this case, when you are going for the project network, you are actually tendering for a project, you will always go for the highest value. So therefore, this is the one that you will actually use it to tender for the project, right? Because as a company, you don't want to pay any penalty for any delay. So in this case, you will always go for the longest time path. So in this case, do remember, critical path is always you are looking for the longest time path, right? So what is a critical path? It's the longest time path in your network, right? How do you actually identify the critical path in the network? The earliest starting time and the latest starting time will be equal for each of the vertex on the critical path. So what does it mean here? That means the EST and the LST value for the vertex in the critical path here, it will be the same. Right? That is how you actually locate the critical path for the network. Let's see how to solve the example 8 here. Determine the EST, earliest starting time, latest starting time, critical path, and minimum completion time for the following network. Activity time are actually in days. You take note of the unit given. So you have to find the EST, LST, critical path, and minimum completion time. Right, so let's start with the first task. Now, how do you do the EST? How do you determine the EST? You start with the starting node, and the value that you start with will be always 0. Right? Then 0 plus 7, you have 7. 7 plus 15, you have 22. 22 plus 10, you have 32. Right? and then 32 plus 5 is 37. You can straight away write it in because there's only one root here, right? Then 32 plus 2, you have 34, right? 34, then you plus 8, it will be 42. I cannot write it in because you have another alternative roots here. So you have 42 here. And 32 plus 8 is 40. Now for EST, when you have more than one alternative path, when there's more than one path, what value would you go for? You will go for the highest value. So in this case, I'll put the 42. Right, so same pattern, it goes on. 32 plus 37 plus 2, I have a 39 here. Same goes to the next one. And 42 plus 3, I have 45. So between 39, 39, 45, which value would have been chosen? Again, for EST, I'll go for the highest value, which is 45, right? And the next thing that I'm going to do is to find my LST. Now for LST, I start with the finished node and I bring the same value as the EST down. I copy the same value and then I backtrace, right? So 45 minus 2, I have 43. 45 minus 2, I have 43. So both now for LST, you always go for the lowest value, and since these two values are the same, so I will just put 43 here. Okay, so 43 minus 5, I have 38. Because there are more than one alternative, I have to write outside, then later I do the selection. So same goes on with 45 minus 3 here, I have 42. So 42 minus 8, I have a 34. 42 minus 8, I have 34 here. 34 minus 2, 32. Now, when there are more than one path for LST, which value would you go for? You always go for the lowest value. So bring the lowest value down there. So 32 minus 10, you have 22. 22 minus 15, you have 7. 7 minus 7, you end up with 0. Now, how do you know that your calculation is correct? Remember, your starting node must be always 0. Okay? Right. Then the third step. How are you going to recognize the critical path? Remember what you learned earlier? Critical path is where each of the vertex having the same EST and LST. So we start with the starting node. The same values, EST, LST, same here. And then you have 22, 22. And you have 32, 32. And you have 34, 34. You have 42, 42, 45, 45. Now let's identify the critical path. This will be the right? You can go from backward to the front or from front to the back. Okay, so the one highlighted in yellow is actually your critical path. You have to write down the critical path. It's A, then I go to B, the B I go to C, and then I go to E, and then I go to H, and then I go to J. What is the minimum completion time here? Those are the value, 45. Can I just write 45? No. Do remember the unit involved here. So it's 45 days. If you don't write the unit in the exam, 1 mark will be deducted. Now let's look at how to solve the example 9. Right, you have to find the EST and LST times for each of the activity in the network. And therefore, from there, you can actually determine the critical paths which gives you the project completion time. And do take note what is actually the unit for the time here. It's actually in days. Okay, now first we are going to start with finding the earliest starting time, right? So for earliest starting time, you always start with the first node and the value will be always 0. So 0 plus 4 is 4, 4 plus 8 is 12, 12 plus 7 is actually 19. Why I write it outside? Because you have more than one paths here. You need to compare. Because EST, you need to find the largest value. So 0 plus 6 is 6 again. Same thing, more than one paths. 0 plus 5 is 5. 5 plus 5 is 10. So between 6 and 10, I'll go for the highest value for EST. So I write the 10 here. 10 plus 11, 21. So between these two, obviously, again, I go for the highest value for EST. So 21 plus 6, I have 27. So this one here, there's only one choice. So I straight away write the answer here. So 5 plus 7, I have 12. Between these two, obviously 27 is the highest value. So there you go, the EST value. Okay, now the next thing we are going to do here will be to find the LST. How do we do the LST? You go to the last node, copy the same value as the EST and bring it downward. Okay, and then you empty the forward direction, backtrace it. So 27 minus 6, you end up with 21 because there's only one choice here. So what you can is you straight away put 21 here. Okay, so 21 minus 7, you end up with 14. Okay, 14 minus 8, you have 6. 6 minus 4, you have 2. Right, so 21 minus 11, because there's only one root here or one path, straight away you can write the answer here as 10. Right, so here 27 minus 7, you have 20. I'm writing outside because there's more than one path, anti-direction. So 10 here, you look at the lower part, LST minus 5 is 5. Right, so between these two, which one is a smaller value? Go for the smaller value and bring it down here as 5. Okay, so now let's look at 10. 10 minus 6 is 4. And 5 minus 5 is 0. So between these three values, 2, 4, and 0, smallest obviously is 0. Now, from here, you know that your calculation is definitely correct. How do you know that the process is actually correct? When the first starting point, your LST value must be always 0. If should you have problem finding 0, that means you have done some miscalculation along the way. Now let's write down the critical path here. So you start with C, D. After D, then you go to G. And after G, you go to H. What is the project completion time? It's actually you find from here, 27. What are the unit involved? It's 27 days.